o11ycon. We have a very full show for you today, so let's get right to it. Please welcome to the stage Honeycomb CTO and co-founder, Charity Majors.
Good morning. Well, this is super weird. It's Saturday and I'm here staring at my own face and welcoming you all to o11ycon at god-awful early in the morning on Thursday. Very strange. It's been 3 years since we've done this. I'm guessing not many of you here listening today were at the first o11ycon because there were only like 150 people. And it was like 3 years ago. But I really enjoyed it. I thought it was one of the best conferences I've ever been to. Clearly not prejudiced in any way. But it was really warm and it was really, it was really special, like seeing like so many people like show up with their own stories of like this brand new sort of cut. At the time observability was just starting to get out there and people were just starting to go, what's the definition? And so we're in a very different place now. And that's exciting too. For our keynotes this morning, you've got me and Miss Nora Jones. We wanted Nora to talk about incidents because it's kind of a different, it's a different lens on observability, right? It's looking at, one of the main levers you can use to both to create high performing teams and to like weaponize high performing teams. It's kind of like a ninja move to spread information and to get like sort of observability into every corner of your sociotechnical system and get a better sense for how these parts interlap. So she's going to be talking about that. And then I am going to be talking about another aspect of high performing teams and observability, which is CI/CD and why everyone should be deploying to production automatically many times a day in 15 minutes or less, because this is the way.
Thanks, Charity. Good morning, everyone. Today, I'm going to be talking about a different type of observability, a different key for it through incident analysis. I know at previous o11ycons, there's been a lot of talk about past outages and what we can learn from them from an observability perspective, looking at different things, but I'm going to take a different approach today. Now, we've all had incidents. This is actually a good thing. There's a positive spin on incidents. They're unexpected, they're stressful, and sometimes inevitable questions creep up afterwards, even if we don't want to necessarily be asking these questions. We ask things like, what can we do to prevent this from ever happening again? What caused this? Why did this take so long to fix? For several years, I studied why organizations through the tech industry were doing incident reviews and postmortems. We all do them, but a lot of folks don't have a good answer for why. And a lot of folks have a different take on it. They do them, they check that box, but we got a lot of answers like, I'm honestly not sure. Management wants us to, it's for the engineers, it gives them space to vent, or like, I think people would be mad if we didn't. We have some obligations to customers, like we owe them this RCA, or we have tracking purposes. We want to see that we're doing better over time. What we got from most of the organizations we talked to through this research study was that everyone agreed that post-incident reviews were important, but we didn't all agree on why they were important. And yet, even though we knew, and orgs knew that they were important on some level, they weren't making efforts to improve that process. A lot of the time, we don't know how. Now, incident reviews and doing better incident analysis can be trained and aided, but it has to be trained and aided to actually be improved upon. And again, I'm taking a different lens on observability today. So I want to do a quick activity. I miss being hands-on and face-to-face in conferences, so this is my way of collaborating today. I want to show you a public RCA, and we're going to take a few minutes to review this RCA. Now, the purpose of this is not necessarily to call out bad examples, but I actually want to see if this satisfies your curiosity. Imagine you were reading this as like an employee at the organization, as a coworker, as a customer. I'm wondering if this actually tells you where to look. So I'm going to read through some of this for y'all. So in this root cause analysis, we have the start date, we have the end date, we have some information about how it was detected, we have the root cause, we have some of the impact, and then we have a bunch of the stuff that we're going to do afterwards. Take a second to digest this real quick. Now, we see that the root cause is that our DNS has scheduled, a restart for security patches, resulting in a simultaneous outage of DNS servers in our environment. And then they have a bunch of action items like, hey, we're going to add this playbook, we're going to update our documentation. I think a lot of these action items and a lot of this root cause and a lot of this impact could maybe be said about any incident. And I think we're missing a big point here. We're missing a point where we can actually dig into and understand exactly how this happened. Incidents are beautiful in organizations in that they're one of the only times where processes go out the window and everyone's doing everything they can to try to stop the bleeding as fast as possible. Now, you learn a lot about your organization during those moments. And it's wasted learning if you don't try to dig into how y'all worked together, who you needed to rely upon, which dashboards you needed to pull up, which systems you needed to interact with. None of those things are actually mentioned in this report, which removes our ability from being able to dig deeper. A good report can actually tell us where to look technically. It can help us focus on the mechanism that triggered an incident and can help us understand how it actually worked in theory or in practice versus how it worked in theory. Now, I'm guessing you all have a lot of open questions about this still, and I'm curious, in the chat, if you could talk about what other questions you might still have about the event. Now, Charity Majors mentioned in a Newsstack article a couple years ago that without access to certain types of data, good luck debugging. And she was talking about high cardinality information or debugging for understanding a system like user IDs and shopping cart IDs and request IDs. But without actually understanding the people and the team dynamics involved in these systems, we're going to have a hard time understanding some of those technical dynamics too. They're symbiotic and they play together in nature. And my talk today is about understanding some of those human aspects of our socio-technical system so that we can understand the technical even better. Now, I want to come back to this. Post-incident reviews are important. I think the organization that I showed thought the incident review was important enough to create one. But they're not great throughout the industry, right? And what's worse is when an incident or event is deemed to have a higher severity, we actually tend to give our engineers even less time to review them and figure out what happened. There was a pretty large incident that happened in the tech industry recently. It had Twitter abuzz, it had LinkedIn abuzz, it had the registrar and all these articles abuzz, and that was the Salesforce incident. Their status page was down, everything was underwater. And yet we saw this RCA, we saw this incident review publicly get displayed pretty quickly after the event, right? Without a lot of time for the organization to learn. Those public reviews impact how we understand things internally too. We can't just slap on more training or more processes after incidents. We actually have to work to understand the mechanisms that triggered some of these events, all the pieces at play that helped lead to the incident. There's a way that you can quantify incident reviews too, right? We don't see a lot of people in the tracking. And I don't mean just calling out a bad actor like, oh, this person wasn't trained enough, we had him or her on call too soon. But there needs to be more interpersonal dynamics. Like, have these teams worked together before? Have they interacted with these systems before? How are these systems actually used? The script that was involved in the incident, how is that meant to be used? We track a lot of metrics today across organizations like MTTR and MTTD, a number of incidents, and all of those things are shallow. Now, John Alspaugh has talked to us about a lot of things before. He says, where are the people in this tracking and where are you? But we haven't changed much as an industry in this regard, and there's little things we can do to help us with that. gathering this useful data about incidents does not come for free. You do need time and space to determine it. And I'm going to talk to you today about how and why giving this time and space to your organizations can actually work in your favor through a couple different stories, new paths on how you can do it in ways that aren't disruptive to your business, and next steps for you to embark on. And spoiler alert, sometimes a thorough incident analysis is actually a mirror. And sometimes it's a mirror that we're not ready to hold up yet. So you have to be willing to see and understand and act on the things that you're seeing that are impacting your business. I'm Nora Jones. I've spent a lot of my career in site reliability engineering. I've done a lot of work on chaos engineering. And in 2017, I keynoted about the business benefits of chaos engineering to 50,000 people about my experiences implementing netjet.com and Netflix. I went on to Slack after that and started a community called Learning from Incidents and Software, where people throughout the tech industry share and understand their experiences with incidents in their organizations. And it's been interesting in that a lot of us experience very similar incidents, right? And sharing this with each other is helping each other grow a lot more. That all led me to starting my own company, Jeli, where we help companies through tooling understand their incidents a little bit better and focus on the socio-technical side of the system. I want to share this quick graphic from organizational psychologist Gary Klein. It's from a book where he studies what makes people experts and how to build more experts in organizations. I think we can all agree that that's something we want. We want more people to be prepared to own the system, to respond to the system. We don't want to have to rely on the same 3 people every time, because then they become people bottlenecks as well. So he has this equation, and this is not something that he just made up. It's pulled from years of research. Performance improvement in organizations is a combination of error reduction and insight generation. You can't have one without the other. So the tech industry focuses a ton on the error reduction portion. That's the counting incidents, that's the MTTR, that's the MTTD. We don't focus a lot on insight generation and dissemination. And what I mean by that is like sharing our experiences with an incident in our organization, getting people to collaborate, getting people to share their own experiences. That is insight generation, and that is insight dissemination. And it is hard to do a good job at it, but that's something that can definitely be improved upon. So I'm going to tell 3 different stories today about how the value of incident analysis brought about in organizations and how we really focused on this insight generation piece. They're based on actual things I've experienced and been a part of, but names and details are changed. So the first story, I'm going to focus on chaos engineering, and this tells you a little bit about how I kind of switched my mindset here. When I was at Netflix, I was on a team with 3 brilliant software engineers. We had spent years building a platform to safely inject failure in production to help engineers understand and ask more questions about the areas in their system that unexpectedly behaved when presented with turbulent conditions that we see in everyday engineering, like injecting failure or latency. It was honestly an amazing technical feat, and I was so happy to be working on such an interesting engineering problem that could ultimately help the business understand its weak spots, right? Figure out those unknown unknowns. But there was a problem to this. And that problem was that most of the time, the 4 of us that created this tooling were also the core users of this tooling. We were using the tooling to create the experiments, to run the experiments, to analyze the results, to find these failure modes, which was interesting because we were running chaos experiments on systems that we didn't own. And so what were the teams that own these things doing? Well, they were receiving our results, and sometimes they were fixing the stuff we found, and sometimes they weren't, right? So why is that a problem? Well, we weren't the ones on the teams for the chaos experiments we were running. We weren't the ones whose mental models on how certain pieces of the system, like search or bookmarks, or what we expected our KPIs to do in certain chaos engineering cases, those weren't our mental models that needed refining, but we were the ones that were getting that refinement and understanding. We were leading the horse to water there, but we were also pretending to be the horse and drinking the water. And sometimes teams would use our tooling. It was usually after like a big incident, or it was before like a high traffic day, or they would put it in their pipelines and kind of maybe forget about it later. But we would have to then remind them again to use it several weeks later. So this was, it was tough, right? So what did we do? Well, we started trying to automate the steps that they weren't taking in order to get them easier access to different parts of the tooling. We wanted to give them more context on how important a particular vulnerability we found with the chaos tooling was. So if we found something like exposing a weakness in the system, we wanted to give them context on how important it was to fix. I mean, to put this in other context for you, like I'm sure you could pull up any repo in your organization and find a ton of bugs. It doesn't mean that they're important to fix in that moment. And that's sort of what we were having with the chaos experiments. Like, how important are these bugs to fix, right? So we need to give them more context on that prioritization. In order to do that, in order to know if something was important to fix, I started looking at previous incidents. I started digging through them and wanted to find things that, like systems that were underwater a lot, or people that we relied on a little bit too much, or people that like weren't on call that we needed to pull in, or things that were really surprising to us and caused a lot of impact. And I wanted to use that as a prioritization algorithm in order to inform if they should run an experiment and what they should do with the results. But I found out through that process of trying to drive more people to my chaos tooling was that incident analysis had a much greater power than just helping the organization create and prioritize chaos experiments. And spending time on that opened my eyes up to so much more, things that could help the business far beyond just driving more traffic to that system. And I learned a secret, and that's incident analysis is not actually about the incident. The incident's a catalyst to understanding how your org is structured in theory versus how it's structured in practice, and it exposes that delta for you. By exposing that delta, you can continuously improve over time, and you can know yourself a lot better. By knowing your org better, you're going to move faster. You're going to move it more efficiently. You're going to understand your customers more. It's a catalyst to understanding where you need to improve your socio-technical system. And it's showing you what you're actually doing really well at versus where you need improvement. I want to lead on to my second story. Now, in this story, an incident had occurred at 3 a.m., which is when all the bad ones occur, right? I was tasked to lead the investigation of this incredibly visible incident the day after. I walked into the office in the morning, and a senior engineering leader had pulled me aside and said something along the lines of, "Hey, Nora, I'm not sure if this incident is all that interesting for you to analyze." And I said, "Why?" And they said, "Well, it was really just human error. Like, Kieran didn't know what he was doing. He wasn't prepared to own the system. We need to have a talk with him about it. Could have waited till morning." Now, this wasn't an organization that thought they were practicing blamelessness. And I want to put that in quotes because I'll come back to that later, without a deep understanding of it and what it meant. A lot of orgs I notice think that doing blameless postmortems or incident reviews is about being nice and not naming names, when that's really not the case. It's making it a safe enough space to name names and to allow Kieran to actually share what was going through his head in the moment. Because if we don't do that, people are just going to repeat what Kieran's doing over and over again and just shove it under the rug further. In this story, like, I don't blame this organization. This could be lifted and shifted anywhere in the tech industry. But when something like this happens, that Kieran makes an error, it's usually met with instituting a new rule or process within the organization without actually explicitly stating that you thought it was Kieran's fault. Even though everyone in the org does think that, and you think that, and Kieran knows you think that, it's still blame. It's not only unproductive, it's actually hurting your organization's ability to generate new insights, like we were talking about earlier, and build expertise after incidents. It's also so much easier to add in rules and procedures. It covers us and it allows us to move on emotionally speaking, which is what we want to do. When something bad happens, we just want to move forward. We want an explanation and we just want to move on. But these implementations of new rules and procedures don't come from folks on the front line. And that's because it's easy to spot errors in hindsight. It's easy to say, wow, he really shouldn't have done that. Unfortunately, adding in these new rules and procedure actually diminishes the ability to glean new insights from these incidents. In spite of not being told to talk to Kieran, I still wanted to talk to him. I wanted to figure out what happened. According to the org, Kieran had received an alert at 3 a.m. that had he spent more time studying the system at play and knowing how to debug it, he would have known that it could have waited till business hours to fix. I came into my conversation with Kieran completely blank, and I asked him to tell me about what happened. He goes, I was debugging a chef issue that started at 10 p.m. We finally got it stabilized, and I went to bed at 1:30 a.m. At 3 a.m., I received an alert about a Kafka broker being borked. Interesting finding number one. Kieran was already awake and tired and debugging a separate issue. I asked him what made him investigate the Kafka broker issue. He said, well, my team had just gotten paged for it, and my team had just gotten transferred this on-call rotation for this particular broker about a month ago. So other brokers were owned by different parts of the org. There was a separate part of the org that owned most of Kafka minus this broker. It was strange, right? I said, had you been alerted for this before? He said, no, but I knew this broker had some tricky nuances, which led me to my second interesting finding. Kieran's team had not previously owned this Kafka broker. Why did they own it? And how do on-call transfers of expertise work? And if this broker is so tricky, why did we put them on call for it after only a month of ramping them up on it? I then asked him how long he's been at this org. He said 5 months. So he was new to the organization. He was on call for 2 separate systems in the middle of the night. I think if I was in his shoes, I would have also answered that page, right? I would have been afraid to just snooze it and go to sleep. And so this led us to a lot of interesting changes in the organization. Rather than just adding up guardrails or maybe taking Kieran off call, we were able to improve how we think about our on-call systems, who we're putting on call for them, how we're divvying them up, how we're ramping up new engineers, automatically changing someone off call if they're on call for 2 separate systems. None of those things would have happened if we hadn't talked to Kieran one-on-one or hadn't given him the space. I want to go back to this. Post-incident reviews are important, but they're not good, but they can be good. Talking to people one-on-one is called cognitive interviewing, and we can use cognitive interviewing to determine what someone's understanding of the event was, to determine what stood out for them as important, what stood out for them as confusing or ambiguous or unclear, and what they believe they knew about the event and how things work that they believe others don't. You have to see what was happening for them in that moment, because they were right in that moment. They were doing those things for a reason in that moment, and extracting that info will improve your whole system later on. And these can be used to glean insight on relevant ongoing projects, past incidents that were related, past incidents that had an action item that led to this incident, or even past experiences. And you can iteratively inform and contrast these with a bunch of other sources of data, like your monitoring solutions or your Slack transcripts or your architecture diagrams, and use these to form a more cohesive view of what happened. Now, my last story is around promotion packets being due. In this organization, and I'll move quickly just through this story, but in this organization, there was an uptick of incidents around certain times of year. And what ended up happening after looking into this was that in this organization, we had managers putting together promotion packets to make a case for their employee to be promoted. And so when the organization grew, this became very, very metrics driven, to the point that people were looking at these promotion packets very quickly. And so engineers were kind of incentivized to push a bunch of stuff that they had agreed to 3 months earlier just in order to get promoted, even if that stuff was irrelevant. And so we saw a lot of merges and deploys happen around the same time around stuff that maybe wasn't super relevant anymore. And guess what? Incidents upticked. And so by looking into our incidents a little bit more and finding themes across them, we were able to improve some of the incentive structures in this organization where we weren't doing promotion packets like this anymore, where they weren't just a big push. Again, a good incident analysis should tell you where to look. You need to make sure those individual incident data points are good in order to see that cross-theme analysis like that. I want to give you all kind of like a different observability chart today, and I want to ask where you would look here. So this is a real incident, and it's showing how people interacted in the moment. So in here, you might be interested in the gaps of absent chatter. You might be interested in the fact that customer service was really the only one talking late on a Friday night. I wonder if they were getting supported. You might be interested in the alert storm from PagerDuty or some of the pull requests that took place. You might be interested in the tenure of folks on the team and their participation level. And you might also be interested if we relied on folks that we weren't actually on call and we needed to unlock tribal knowledge. I want to quote something that Charity said before. She said, when you're flipping through a bunch of dashboards trying to figure out what's happening, you aren't expecting and reasoning about it or following a trail of meaningful breadcrumbs. You're jumping straight to the end as a guess. It's through the entire system it's though the entire system were a black box and you had no information to reason about what happened in what sequence. This can help you reason about it better. It can help you dig into what people were looking at particular times, how they were debugging things. A good incident analysis can help you with a lot of things. It can help you with headcount, with training, with promotion cycles, with structuring your teams and your organizations, with understanding who came into your incident that wasn't supposed to, and understanding your bottlenecks. It can also help you understand your technical systems a little bit better. It can help you figure out what you need to focus on that everyone's kind of confused by and understand where to instrument things. Now, not every incident needs to be given more time and space to analyze, and there's a little bit of a formula for this. You can look at ones that have more than 2 teams that were involved, especially if they hadn't worked together before, or ones that involved a misuse of something that seemed trivial, like expired certs. There's usually more to look at there. If the incident or event was almost really bad, if it took place during something like an earnings call, if a new service or interaction between services was involved, or if more people joined the channel than usual. Now, I definitely have a lot more to share on incident analysis and some of the things you can learn from it. Some of the ways that you can find out about this are the learningfromincidents.io website, where we open source a lot of our learnings through the tech industry. We're also working on a lot of these problems at jeli.io. Thank you so much.
Nora, thanks. That was so awesome. I feel like I've heard little bits and pieces of that talk over the last few months or however long, but I don't think I've ever heard it all together.
Yeah, thanks. It was it's definitely a fun experience talking about a different portion of observability, right? And it's like, yeah, we can use some of the human systems involved to help us understand the technical a little bit better. And I think that gets lost on a lot of organizations, and it's a big miss.
In your experience, like, because obviously there's a lot of feedback looping going on here, but when you're talking about all the ways that, doing this sort of, analysis can make your teams better, do you find that it's typically, it takes a high-performing team to do these sorts of analysis, or are there teams that are, scrappy and, the bottom 50% of the door metrics that actually use these techniques to kind of lever themselves up?
Yeah, it's a really good question. It doesn't have to just be high-performing teams, but it does have to be shared by leadership, like, hey, we want to give folks the time and space to learn. Otherwise, people are just going to spin their wheels more. But my favorite story, I was working with an engineer that was a senior engineer at an organization, and he had been trying to get promoted to staff for like 5 years. And he was so frustrated that he wasn't able to get it. And we started coaching him on incident analysis and like running incident reviews better and how to understand different parts of the system. And at the end of that training, he goes, Nora, I'm seeing in color now. Like, I realize I'm not just being trained on being a meeting facilitator. I now understand how this system works in ways that I don't think a lot of people at this org do. He got the staff engineer at the end of that, not just because he was running more postmortems, it's because he knew who to talk to. He was merging things in design reviews. He was able to poke holes in things before they hit production. Like,
he knew he could better navigate both the technical systems and the human systems. I mean, we throw this word sociotechnical around a lot, which I love because it's one of my favorite words. But something that an example that I've used a couple of times recently to try and drive it home is that, like, if you take like the New York Times, which has a great engineering team, right? And you send their people all to Cancun, but you replace them by engineers that are equally as experienced, equal skill sets and everything. Like, how long would it take them? And then like the site goes down. Like, how long would it take the new ones to like figure, like, first they have to like just figure out how to log into the systems, you know, like so much of the system is literally like it's in your head and my head and it's in the team's head. Like humans are not fungible. Like they're part of the system.
Yeah. Yeah. And like one of the reasons I really harp on tenure and stuff is because guess what? In the tech industry, when people vest, they usually leave organizations, right? And they take a bunch of that knowledge with them.
Yeah.
And so it's of the organization's best benefit to invest in learning and continually training your people. If that group of folks left and you replace them with equally experienced engineers,
they don't have all that context in history.
They don't have that context.
They don't have that gut feeling, that intuition. Yeah. And even if they write it all down, like that's a pale imitation of having lived through the experiences, you know. And something that used to make me really, still makes me really bitter is when, you know, CTOs and CIOs are like, you know, they're clearly looking for a vendor to tell them, give me millions of dollars and you'll never have to like, your engineers will never have to understand your systems again, right? We'll tell you the answer. We'll show you the answer. We'll tell you what's happening, you know, because from the perspective of an exec, sometimes it's like people come and go, but vendors are forever. I hate that, right? Yeah. But I like the way you're kind of turning this on its head and you're going, you know, but we can invest instead of just investing in like these robot systems, we can invest in our human systems so that we can better tolerate the coming and goings of humans, so that it's actually its strength, right? Like if you're regularly rotating your engineers in and out of teams every couple of years, there's not going to be these like hairy corners where only two people know what's happening, right?
Exactly.
Consistency.
Yeah, it levels everyone up, and also by if you like, and the incident review shouldn't just be run by like the one lone SRE.
Completely.
Because if you spread out who's running the reviews, then you start leveling everyone up. Because when you, I don't know if you've ever, like even giving a talk on something or giving an incident review on something, like you mentioned I wrote the chaos engineering book, and I knew a lot about chaos engineering before I wrote the book.
Yeah.
I learned way more about it through the process of writing the book. And that's the same with incident reviews, is you learn more about it. And so by investing and allowing all these different people through the organization to do stuff like that, the business benefit
everyone up. Yeah. Creating a lingua franca, and you're both creating and reinforcing an internal like team practice and culture that everyone can participate in, and it not only makes them better engineers, but it also it's binding, you know. It's one of the things that can really bind people together.
Yeah, it encourages teamwork, right? It encourages.
I love what you said about it's not about not naming names, it's about making it safe enough that you can name names.
Yeah.
Oof, I've never heard that before. I was just like, damn, that's so true.
I've seen so many organizations that are like, we're blameless, so we're not going to mention Jack's name.
We're not going to say the name of the person who took everything down. Right.
Like that makes it so much worse. Like you're actually
knows. Yeah.
A million times worse by not doing that. I want to know the name of the person, because you can find it out anyway. You can find out that it was Jack that did the pull request. Yeah. So why not just put it in the review? Yeah. Right. And if you can't do that, that is something that you need to go fix in your organization.
We're not ignorant, it's blameless.
Exactly. But I want to know about Jack's tenure. I want to know what teams he's been on. I want to know like how they come from. Exactly. Yep.
That's super interesting. Yeah. Well, thank you so much for being here, Nora. I think I'm going to give a talk now, and then Nora's going to stick around. We're going to dissect mine afterwards too. So we'll be right back.
Thanks, Charity.
All right. My turn. My talk is going to be about, a little bit of everything. CI/CD, observability, teams, TLDR. It's time for us to finally, as an industry, fulfill the promise of continuous delivery. For those of you who don't know me, I am the co-founder, CTO of Honeycomb. I co-wrote the database reliability engineering book with Liz Fong-Jones, and the observability engineering book with, I co-wrote the database reliability engineering book with Lane Campbell, observability with Liz and George Miranda. It's out in pre-release, so if you want it, you can download it. So, how well does your team perform? This is one of these fun, uncomfortable questions. But please note that it is not the same as asking, how good is your team at engineering? It's a very different question. High-performing teams are teams that get to spend most of their time solving real, interesting, new problems that move the business materially forward day after day. It's dope. It's a great career, right? You're a creative software engineer. You get to build sandcastles in the sky. Lower performing teams spend most of their time not doing those things. It's a lot of firefighting, waiting on each other, solving problems over and over again, fighting with their tools, yak shaving, a lot of toil. And if you're wondering how high performing your team is, I always recommend that people start with the DORA metrics, right? How often you deploy, how long does it take, how many fail, and how long does it take to recover when they do fail? I always add a fifth one, which is just how often does your team get paged outside of work hours? Because that tracks really, really closely with how quickly are they going to get burned out. There is, if you've been paying attention over the last few years, there's an enormous gap between these so-called elite teams. I'm not really fond of that term. I tend to call them high-performing teams, and the bottom 50%. You know, elite teams deploy many times a day. The bottom 50% between once a week and once a month, right? Like the time to restore service goes from less than an hour to like between 1 week and a month. Oh my God. And if you look at them year over year, well, the top 50% is, you know, it's achieving liftoff in a way. Like people are getting better and more people are getting better faster because the tools are getting better, because the practices are getting better, because we're all sharing them, right? But the bottom 50% are actually losing ground because in software, if you're standing still, you're actually like entropy has got you. It really pays off to be on a high performing team, like a lot. 208 times more frequent code deployments. Oh my God, right? So obviously the next question is, how do we make these high performing teams? And the answer obviously is hire the smartest people and the best engineers, probably from MIT and Stanford exclusively. Wrong. It's actually the opposite. It works in the opposite direction. There is a lot of like tight correlation, but it works in the opposite direction. Great teams are what make great engineers. Just like think about it. 2 kids straight out of school. One joins a high performing team on the left. One joins a medium performing team on the right. Who's going to be the better engineer in a couple of years? The one who gets to deploy constantly and who spends a tiny fraction of their time like firefighting, or someone who gets to deploy 5 times a year? Every time you deploy, it's an opportunity to learn. First and foremost, right? You build something, you deploy it, you learn something over and over again. If you're only getting to learn something 5 deploys a year, well, that's kind of a wrong way of putting it. You're probably learning something, some things. They're just not likely to be very fun things or useful things or the things that you want to be learning. And just to drive this home, like what happens with it when an engineer from, say, you know, Google, Facebook joins a team, you know, in the blue bubble? Our intuition often thinks that, well, they'll bring them up to meet them, but it's not so. Your productivity tends to rise or fall to match that of the team that you join within about 6 months, because most of the act of shipping software safely, securely, swiftly has very little, relatively speaking, to do with your personal ability to write good code. It has much more to do with the sociotechnical system that you participate in. It's all about, you know, the deploy systems that are in place, the CI/CD story that you have, how long it takes to get your code reviews turned around, how many automated checks there are and tests there are to catch things, so that you can automatically fix them before they get, deployed live. Which is why anyone who thinks of themselves as a technical leader, not just managers, but definitely managers, technical leadership needs to focus intensely on constructing and tightening those feedback loops at the heart of the system. I believe that if our leadership class spent half as much time and energy and vigor in tending to those tight feedback loops and keeping them short, as they do to interviewing and like setting a bar and trying to like make sure that new employees meet the bar, the technical bar. I think if you switched your focus to like creating those feedback loops, it would be time well spent. It would be easier on everyone, and you would get better engineers out the other side. Sociotechnical is a great word. It's one of my favorites. One of the reasons that I like it is because you immediately know what it means. But in case you didn't, there's the definition. And this brings us to CI/CD, because shipping is the heartbeat of your company, as my dear friends at Intercom like to say, which means that shipping new code should be as regular, as ordinary, as boring, as commonplace, as unremarkable as your heartbeat. It should be small. You don't want to bang the drum at every heartbeat. You want it to be consistent. You want it to be regular, and you want it to be, you don't want to have to think about it, right? You want to be thinking about the code that you're writing. You don't want to be thinking about shipping the code. CI/CD is, nominally speaking, how we get there, right? So if I ask you, do you do CI/CD? Of course you do CI/CD. Everyone that I've ever talked to says, well, of course we do CI/CD. Of course, when you drill into it, often it means, well, we have a Circle CI account. We run some automated tests. Cool, right? No. Most people at this point are doing CI or a derivative thereof, but CI is only it's the prelude. It's the precursor to the main course. The entire fucking point of CI is to clear the path for you to be deploying constantly, because continuous deployment is what will change your life. Years ago, when the book was written on continuous delivery, they used a lot of weasel words here about how it was getting your system to a state where it was ready to be shipped at any given time, as though that was good enough. Well, it was good enough at the time because they were shipping shrink-wrapped software, so they had an excuse. You probably do not. If you aren't going to hook CI up to production and ship it automatically, honestly, why even bother? Just set up a bash loop while zero in parents. Run your test continuously in shell loop. Less hassle, same result. Because any CI/CD job that ends without having deployed your code to production is a failed run. I've been harping on about feedback loops a bit here, so I want to kind of back up and go, what does a good feedback loop look like? Instead of just criticizing everyone. Glad you asked. A good feedback loop looks like this. An engineer writes some code, small amount of code, merges a set of changes to main with any user visible changes hidden safely behind a feature flag. It should automatically trigger CI to run tests, build an artifact, and deploy that artifact, either straight to production or to a staging environment, which will then be automatically later promoted to production. There are a couple of very important things to note about this. Oh, and the time elapsed should be 15 minutes or less. Very important. Important things to know about this. One change set by one engineer per artifact, period. No manual gates. I don't actually care if it takes, an hour or two for it to, be deployed to staging and then, promoted to super staging and then, promoted to production. Like, I don't care. That counts as long as there's no manual gates and no variable times, right? It should be predictable. It should be something that your body clock can just like hook into and go, yep, I'm merging. I know that in 5 minutes it will be live and I will go look at it. Because if you're an engineer and you're merging some code and you know that your changes will be live and users will be using them in 5 minutes or less, you're going to go look at them through the lens of the instrumentation that you just wrote. On the flip side, if you're an engineer who just merged some changes and you know that at some point in the next 6 to 48 hours, your changes and anywhere from 0 to 20 other engineers' changes will have been shipped to production, you're not going to go look at it. Nobody's ever going to go look at it, right? It's important that feature flags are hidden behind user breaking changes are hidden behind feature flags, because this is what successfully decouples deploys from releases. I'm super sympathetic to the fact that, product managers have, and marketing people have, stuff to plan and schedules and everything. And nobody's saying we should be jerking all of our users around just like, willy-nilly. Deploying releases, severing deploys from releases is a really critical part of this. This is the way. Favorite use of meme this year. I'm so stoked about that. What's important about this is that precious interval between when you wrote the code and when the code is deployed, because that time, keeping that time small as possible is really it's not everything, but it's a lot. It's a difference between software engineering being a creative, fulfilling career, and you being just a Jira ticket taking like machine where you just take the tasks and you crunch them out. I firmly believe that. Part of this is because software, once it's been written and has not been deployed, it ages like fine milk. At that moment when you have just finished solving a problem and you're merging your changes, you've just gotten them reviewed and you feel good about them. You know everything about, as much as anyone will ever know about your original intent there, what you meant to do, why you meant to do it, implementation details that you tried and discarded, the trade-offs that you had to make, down to the specific variable names, like everything's fresh right here, and if you go and you look at users using it right then and there, you are primed to be able to notice, oh, that isn't quite what I meant it. Well, that's higher than I expected it to be. Oh, this is a little weird, right? You can never get that back, and neither can anyone else. And that state of mind begins to degrade as soon as your focus is shifted from this software to the next thing. It lasts for minutes, maybe, which is why engineers can find, 80% of all bugs or more in that magical, fleeting 15-minute interval, so long as they have good observability tooling, they instrument their code, and they habitually, muscle memory, go and look at it. Just ask yourself, is it doing what I meant it to do? Is anything else look weird? It lets you hook into the body's own intrinsic reward systems. Dopamine, muscle memory. It's so good, right? You do this for a couple days, a few weeks, and then when you merge code, like you get this antsy feeling in your body, like you're not done yet. You're not done yet because you haven't closed the loop. You haven't looked at it yet. You haven't gotten your dopamine hit yet. Finding bugs before the users have found them, it's the best, right? Having a very short interval, it's not all about your attention. It's a lot about your attention, but it also really helps you hold the line against batch deploys so that you have one engineer's change per artifact per deploy, which leads you to software ownership, right? If you don't have that, it starts to get grim really fast. And in fact, if your interval is not 15 minutes, but more on the order of hours or days, you're almost definitely batching people's changes together. You're almost definitely not deploying automatically. And then you enter what I think of as the software development death spiral. It starts with the longer interval between when the code is written and when it's deployed. But this leads to people writing larger diffs, longer turnaround for code review, a lot more time spent paging state in and out, changes getting batched up, severing ownership, makes it hard to identify whose code is at fault. More and more engineering cycles get spent waiting on each other or debugging things uselessly. I mean, anytime you've just shipped a change with, 25 people's changes in it and it fails, you're in for a bit of fun. And so is everyone who has a change wrapped up in that mess, right? It's going to take you the rest of the day, more than likely. Just give up. So now you need an SRE team. You might even need like a build and deploy team. You probably need a release team to like try and, automate a bunch of this stuff. you know, now you've got specialists, you've got teams. Teams need managers and more coordination costs. You need product managers and project managers. Everything takes more time, and you're spending, like, the coordination costs are enormous. You could either spend your entire life as a technical leader chasing all of the symptoms and pathologies that flow forth from this, or you can fix it at the fucking source. 15 minutes or bust. How much is your fear of continuous deployment costing you? Well, I have a rule of thumb, which is that, if it takes, say X number of engineers to build, maintain, and run your software at 15 minutes or less delivery interval, it'll take twice as many engineers with an interval of hours. With an interval of days, twice as many again. Weeks, twice as many again. And if you think that I'm exaggerating, well, you're right that I've mostly pulled this out of my ass. I mean, not completely, but it's not like I've done like research studies on this. But the evidence suggests that, if anything, I am actually being too conservative, because the best data that we have was the stuff that was done by Facebook, where they very rigorously showed that the costs of solving a bug go upward exponentially, beginning the moment the bug was written. Like, exponentially more expensive to find, isolate, reproduce, understand, solve, test, ship, etc. If you ever looked at one of those companies who has like 200 engineers and you're like, how does it take you that many people to do that? What much amount of work? So just saying. Well, have I got a proposal for you? Fix your fucking build pipeline and let's find out. It isn't just about the economic arguments. How well does your team perform? Like, this is, just to remind you, high-performing teams get to spend their lives solving fun puzzles together and having a lot of impact and, moving the business forward and being, more successful. Lower-performing teams do not. It's a grind. It's a drudge. It's not fun. Which means that, like, this is more than just an economic issue. It's also a quality of life issue, right? It's an ethical issue. I'm tired of hiring people into teams, and just having them just look like dead in the eyes, or having them like distrust me when I tell them what, how the process of shipping software. It doesn't have to be that bad. The number of cycles that technical leaders spend on curating and tending to the internal feedback loops by which the software gets made manifest is microscopic. And I gotta say, like, no one who's worked with true CI/CD is ever willing to go back. So it's really good for hiring, and it's really good for recruiting and retention. TLDR, by focusing on these inner feedback loops, by focusing on like how the sausage gets made, we can build a better, more humane generation of sociotechnical systems that build the next generation of great engineers, right? We can build the great teams that foster the great engineers. We can build systems that are well instrumented, that are well understood, that are not just like, several years of like whatever got coughed up in a hairball and like shoved under our beds. They can be well understood by their makers, and therefore they can be not noisy. They can be compatible with being an adult, having kids, having families, having other responsibilities, right? And all we all want out of our jobs anyway is to work on teams that are low in toil and high in autonomy, mastery, and meaning. And how? Well, hire people who share your team's values. Spend time investing in your sociotechnical feedback loops. Add instrumentation and observability. You wouldn't go driving down the freeway without putting on your glasses, would you? I'm not talking about monitoring. I'm talking about observability. You practice observability-driven development, and then instrument, observe, iterate, ship, and repeat. It's not that hard. It's literally not that hard. The way that you're doing it now is the hard way. This way is easier. Are you too busy to improve? I hope not. The end. All right, I'm done.
That was awesome, Charity. I really liked your talk about, burnout and increasing coordination costs too. And it's interesting. I feel like when people think they're not shipping enough, like an immediate reaction is like, oh, we just need to hire more people. And then
yeah. And it's so costly. I mean, sometimes it's got to be done, but like it's not usually, and I feel like I don't like to give more headcount to any engineering manager who's underwater.
Yeah.
It's because until they've learned how to say no, until they've learned how to like have the right amount of work for their team, like I would so much rather give headcount to an engineering manager who's like, I'm like, you're doing such great work. I want there to be more of it. And they're like, cannot do it until you give me more people. And I'm like, please take more people. Right? Like that's the dynamic that should happen.
Yeah.
More people is a mixed bag for sure.
So you talked a little bit about like shipping quickly, and I'm curious how you think staging environments and our attitudes towards them impact content shipping.
Death to all staging environments. I say this, but believe me that we have like 3 of them at Honeycomb or 4 of them. My beef is not with staging environments. I think they have a lot of really good uses. I just think that historically we have spent like almost all of our engineering focused time and energy on staging, just like making it elaborate and like, all the tests and like, we're going to be so sure and everything. And then when it's like, well, what about production? It's like, well, we don't have any time left over for that. Like, know, and I feel like we should, if we spent all of that engineering effort, we spent 80% of the engineering effort on production first, making it safer to ship, making it so that there are guardrails, so that there was instrumentation and observability, making it so everyone knew how to deploy, revert their changes, and making, great, and then if we were like, gave our leftover dev energy to staging, then I think all would be well in the world. Right. Yeah. So I'm not abolitionist. I'm just like, there's been historically mismatched, but I feel like the last 5 years, this has started to shift, right? Like, I feel like the gravitational, it's started to shift away from pre-production to production. And I think that you see like all the little startups that started bubbling up, like, us and Gremlin and Launch Darkly and you guys and all the folks who are like, production is literally the only thing that matters, And I think that people are starting to get there. It's scary, right?
Yeah. And it feels like it'll help at first, but it actually, like you said, it increases your coordination costs. It leads to more burnout, which totally impacts high performing teams. And then you don't end up with a high performing team anymore.
Another thing that I feel like people haven't quite internalized is that as an engineer, you have maybe 3, maybe 4 hours a day of engineering labor in you. That's all you get. That's pretty inelastic. You can spend a lot more time at work doing things, but when it comes to the focus that moves the business forward day by day, you've got 3 or 4 days, 3 or 4 hours a day in you, honey. Like, that's it. So like, try to make the most of it and try to make sure that you're actually moving the business forward in those 3 or 4 days. But like, there's no excuse for anyone to be burning themselves out. No one can write good code for 12 hours a day. Can't be done.
Right.
Thanks so much for joining me. It was really fun to have you.
Thanks, Charity.